Hi everybody, my name is Charlie Kepler. I'm an applications engineer and lead pilot here at Headwall Photonics, and today me and Carson are going to go through giving you a demonstration on how to use the Co-Aligned HP with LiDAR on the FreeFly Alta X. So the first thing we're going to do is get the system all connected, powered on, and the Ethernet cables plugged in, and then we're going to launch HyperSpec 3. In HyperSpec 3, we have this sensor drop down for both sensors. There's the SWIR and the VNIR. So we're going to open up the live video on both sides. And now we see our spectral plot here. And for the SWIR, we're going to hover over the peak of the curve here such that our plot is about 80 to 90% of saturation, so around 50 to 60,000 counts, which looks like here I'm at 51,300, so I'm going to say that's probably good. I want to make sure I click this X hair button to be sure that I'm looking at a uniform region, somewhere that's not one of these dark spots, and so I think that looks pretty good. Otherwise, I would adjust this exposure up or down if I needed to make the curve go up or down. I'm going to do this similar on the VNIR side, so click the X hair, and make sure that the top of my curve is about, like I said, 80 to 90% of saturation. For the VNIR sensor, that is about 35 to 3,800 counts, which it looks like I'm at about 3,850, so I'm going to call that good. Once I have my exposure set on both sides, I want to adjust my frame period such that it's greater than or equal to the exposure with a minimum of 200 hertz or 5 milliseconds. I'm going to set the gain level to high for both systems for an airborne application, and then set my distance to object to my flight height, which today is going to be 60 meters, and that gives me my suggested speed of 5.860. I'm going to take that 5.860 and subtract approximately half a meter a second and enter that as my flight speed in my flight control. Once I'm happy with this window, I'm going to close out of both of those and then move on to the GPS tab. Again, I'm going to do this for both systems. And it looks like I have a polygon that was loaded previously, but I'm going to import polygon file and select a new one. Okay, there we are. And I'll do the same thing on the other side. We see here this little X, that's our location. We have a smaller polygon for where we're going to fly over the tarp, and then a larger polygon where we're going to fly over the front parking lot. So once I'm happy with that, and I'm seeing that I'm getting altitude, latitude, longitude values, and the bottom left is green, meaning we have a GPS lock, I'm going to say we're good to go and close out of those windows. We can skip the calibration tab, that's only for lab-based systems, and move on to the capture tab. Use onboard storage, yes. And here now we have the two sensors as these two tabs. We're going to give it a folder prefix, so today we'll call it CAHP159, that's the serial number, and then Alta X demo. I want to leave these pretty much at the defaults. The only thing that I'm going to change is for the VNIR side, the NHP. I'm going to change the frames per cube from 2,000 at the default to 1,000. That will give me approximately similar size files on both sides. It automatically brings in the exposure and frame period that we found before. And we're going to use max number of cubes 0, meaning we're not going to restrict how many data cubes we collect. Once I'm happy with that, I'm going to click this Collect Dark checkbox, and it adds _dark to the file name. And then now we're ready to take our dark reference. So I'm going to take the lens cap and put it on. And now I can say, go. Is the lens cap on? Yes. I hear the shutter open for the SWIR. The VNIR does not have a shutter. That's why we use the lens cap. And it should take about 5 seconds because our frame period was 5 milliseconds and it's 1,000 frames for the dark. Once that's finished, Now we're ready to click this Enable GPS Triggering. Active polygons 1, even though there were 2 polygons in the file I loaded, we loaded 1 file and it considered it as 1 polygon because they were connected by a little line between them. There's some advanced settings here which we advise not to change. You want to make sure your altitude is 0, 0, and that way you won't restrict your collection based on your altitude height. So we have our name, we have our settings all filled out, and then we have enabled GPS triggering checked, and we're ready to say go. Is the lens cap off? Yes. Once I click that, I see this little pause icon show up, assuming I'm outside of the polygon. That means that the system is armed and ready to go. It's just waiting for a GPS command saying it's inside the polygon to start collecting hyperspectral data. At this point, I can close out of the software and open up my flight control software. And here I'm going to make sure I have the antenna plugged into my computer and then selected the correct UAV from the drop-down list once it shows up. So this is the PX4-1 for the Alta X. And I'm going to say upload to drone. If I need to change any speed or anything like that, I can, but I've already loaded this flight plan and I'm happy with it. So I'm going to say upload to drone from route start. And route successfully uploaded. So now I can click on this telemetry and control, and I can either start the mission from this control tab, or I can start it from the switch on the remote control, which I'll do from there instead. But I can see my battery and some other telemetry info here. And at this point, I'm ready to disconnect. Okay, we're going to unplug the Ethernet cables, and then make sure we plug in the white LiDAR cable into the V-near port. And now we are also streaming LiDAR data. And at this point, I can ask Carson to help me move this to the start location. So we're going to pick it up. The Alta X is a 2-person lift. Fix it like that. Now I'm going to do a quick pre-flight check. So I'm going to check the legs, standing on them and pulling up, make sure they stay in place. Check the rotors and the arms. Make sure this guy bends but doesn't break when you flex it. You want to make sure your levers are engaged on both sides. Make sure your drone tag remote ID module is powered and blinking white. That means you're broadcasting your remote ID signal. Want to make sure this is breathing green. That means it has a GPS lock. My straps are strapped and they don't break. I have this little antenna pointing down. And then just check this other leg. So that all looks good to me. I want to make sure the arms are extended. So at this point, I am ready to take off. So I'm going to have everybody step away from the UAV. I am at 49 volts, and it is 11:48. Check all my stick positions. They are all good. And so now I'm ready to power on the system, arming the drone. And left stick to take off, taking off. I'm gonna go up to a safe altitude, above any trees or anything like that. I'm gonna point away from my collection area so I don't fly into the polygon. I zero the throttle, and then I'm going to go left stick or right stick full forward for 3 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi, and then full stick backwards until I come to a complete stop. Rotate 180 degrees and do the same procedure back to the start. 1 Mississippi, 2 Mississippi, 3 Mississippi. Full stick back until I come to a stop. Now I'm ready to start my mission. And then for the Alta X, I want to have my first waypoint be slightly behind me, and I want to be facing back towards it, up at approximately the correct flight altitude. So I'm going to look at the screen now, just see where I am. And it looks like I am in front of it. I am facing back. I'm at 53 meters, so I want to go up to 60, so go a little bit more. Okay, I'm at or around my flight height, and I'm ready to flip into mission mode. At this point, it is now under autonomous control, and I'm going to watch, make sure it's doing everything that I told it to, and if I need to, I can intervene and take over manually. So I'm going to stop the mission a little early. We don't need to do this whole thing. So I'm going to go back into position mode and then bring it back for a landing. Before I land, I want to do my the same initialization procedure at the end of the flight as well, if you have sufficient battery life. This is beneficial for the GPS post-processing. So I'm going to go 1 Mississippi, 2 Mississippi, 3 Mississippi, stop. Turn around. 1 Mississippi, 2 Mississippi, 3 Mississippi, stop. And now I can bring it back for a landing. At this point, we can bring the UAV and the sensor back to our table or our cart and stop the acquisition. We can unplug the LiDAR. Plug in the Ethernet cables. 46.9, and it is 11:54. Once we're connected, we can go back into HyperSpec 3. Obviously put the lens cap on back at the end so you don't lose it. And then we click capture and stop. We see we took 2,000 frames for the hypercore, and the Veneer doesn't list how many frames it took.